Hello, welcome to our presentation. We are Applied Optimization and I am Anil Chowdhury. We are located in Dayton, Ohio, and our project is on scientific design of AM process parameters. Our objective is to support component qualification. Our solution combines the material science, laser material interaction, equipment parameters, part geometry, scan path, and optimization methods to design process parameters. This technology is relevant to produce high-quality critical components using AM and to widen the supplier base. Our solution is AMP-squared software, or the Additive Manufacturing Parameter Predictor. Our design for AM process parameters begins with the AM material thermophysical parameters, which include phase change from solid to liquid to vapor. We consider the laser parameters, that is, spot size, energy distribution, absorptance of laser energy, keyhole formation, etc. We account for the scan path specification and the melt pool formation as a function of local geometry of the layer and the part. We account for the residual heat buildup through a combination of layer-by-layer analysis, track-by-track analysis, and feature-specific analysis. We mitigate defects by attaining consistent melt pool formation, accounting for the non-uniformity of residual heat buildup, hotspots, and part geometry. We optimize most of the parameters allowable for commercial machines. This includes the usual laser power, scan velocity, line spacing, as well as special parameters such as the core offset, contour offset, multiple contours, etc. The parameter prediction uses automated algorithms so as to minimize the manual effort. The solution method is simple enough to be used by undergraduate interns. This is important because the simulations can be performed at a very low cost. So, how do we design parameters? The usual experimental trial and error is too expensive and only provides a point solution which is difficult to reuse. We use analysis to identify critical, highly stressed regions. We optimize build orientation to provide favorable AM build conditions for critical regions. We extract thermally equivalent test samples for initial testing of process parameters. We optimize process parameters, accounting for the thermal and geometry conditions in the part. We design parameters to minimize or eliminate at surface and near surface defects. This approach provides the simulation user a right balance for nonconformity and critical thinking. Primary interest for the Navy is qualification of AM parts for sustainment, to provide surge capacity, and to replace cast and forged components. High quality defines the need to minimize build defects and to attain consistent mechanical properties for a variety of part geometries and build materials. Low cost defines the need to reduce the cost of AM parts. Rapid defines the need to reduce the time for AM process development. Our solution is to use science-based AM parameter prediction, which is captured in our AMP-square software. The operational need and improvement is the ability to produce the part using a reliable and repeatable AM process, attain consistent mechanical properties, and that there are sufficient options in the supply chains to produce the part. We have attained cost of simulation to be less than the cost of experiment. One of my mentors told me that a solution is good when it is simple enough to be used by a smart 10th grader. We are not quite at a level where a solution is simple enough for a 10th grader, but it sure is simple enough to be used by undergraduate interns. In fact, most of our simulation work is done by undergraduate students. This is possible because of the automated algorithms which make it simple. Also, the cost of simulation is low because the training is simple. It takes about 2 weeks to learn the simulation. The turnaround of simulation times is quick. We are a small business and we routinely run 50 or more simulations each day. Our scientific method has won several awards. First, America Makes Award for Digital Thread at Data Analytics, DARPA Award for Part Scale Thermal Modeling, America Makes Award for Scan Path Generation, Air Force Third Place for Melt Pool Modeling, and NIST Award for Solidification Microstructure Modeling. A key benefit of using our solution is to minimize experimental trial and error for parameter design. A simulation is useful to provide a scientific explanation for the experimental observations. We can also find options to solve the problem. The solution is scientific and reusable. Each experimental outcome can be analyzed to enrich our understanding and grow our knowledge of the AM process, how the part geometry and the process parameters affect the outcome, and choose the best option. For transition to fleet, reusability and reliability of solution to produce high-quality parts is a key metric. Our product AM2 is a reusable solution to produce high-quality parts. We consider part geometry as a collection of interior and boundary regions. We account for upskin, vertical skin, and downskin features, local thermal conditions, hot spots, and provide options to minimize build defects. We provide ways to minimize or even eliminate at-surface and near-surface defects, allowing hot isostatic pressing to heal all defects. The process parameters can be leveraged to produce one part on different machines. The process parameters can also be leveraged to produce parts of various different geometries. We are currently working with 2 aerospace organizations to demonstrate the reusability and repeatability of our scientific method. Analysis or opportunity. Our objective is to reduce time and cost for AM part qualification and widen the supplier base. Thus, our solution can map AM process parameters from one machine to another. This is due to the method used to design the AM process parameters. This is useful to widen the supplier base and reduce costs for AM through market competition. And also, the science data is useful to support machine qualification. Partnership for transition. We would like to work with you to demonstrate how you can reduce cost and time for AM part qualification. We provide training so that you can use our solution to design process parameters for complex AM parts within 2 to 4 weeks. You can minimize defects. You can use the simulation results to provide data pedigree to back up design decisions. You can use the simulation results as a part of technical data package and TDP. This is all towards reducing the cost and time for AM part qualification. We invite you to reach out and work with us to reduce the time and cost of AM part qualification. We are Applied Optimization. I am Anil Chaudhary, and please see my contact information on this slide. At this conference, please come see demonstration of our AM Analytical toolset at our booth. We have test samples and we can work with you to predict and optimize the AM process for your part. We are located in Dayton. We are just 4 miles from the AM AFRL Materials Laboratory and across from Wright State University. If you happen to be in Dayton, please stop by. We look forward to seeing you. Thank you for your time.